Neutrons interact with nuclei through nuclear interactions. But they also have moments. So they interact with unpaired electrons through dipole-dipole interactions. So this shows the difference between neutrons, X-ray, and electrons. Electrons penetrate a material very, very little. It's a surface probe. X-rays penetrate the material a bit more than electrons, but not much. It's again a surface probe, fundamentally surface probe. That's why when you make a crystal, single crystal determination with photons, with X-rays, you use a very, very small crystal, and still you have to correct, okay, so absorption effects. In the case of neutrons, diffraction effects, it penetrates very deeply the matter. For this is for the magnetic scattering. This is the elastic scattering. It hits it interacts with the nuclei, and it's scattered. And here interact with electrons in the atoms, and through dipolar interactions, and has some scattering effects as well. Interacts much weaker than X-rays and electrons. Therefore, neutrons can penetrate the matter into much deeper into matter. This is according to atomic number, how neutrons penetrate the depth in meters. So this is, look, these are centimeters. Okay, this is X-rays and this is neutrons. Electrons. So X-ray and electrons, for most purposes, because at very low atomic number with X-ray, we cannot distinguish much, are surface probes. This is 10 to the minus 4 meters. Okay. Instead of with neutrons, we have deep penetration, and that gives very good conditions for environment control. If you have made X-ray studies at very low temperature, helium, or under pressure, you see that it's very difficult, because you have to let the X-rays penetrate easily to the crystal. Instead, with neutrons, that is not a problem. You have a big cryostat, and you can put your sample in. And the neutrons will penetrate the different thermal shells in the cryostat, get to the sample, and diffract, or scatter. The same for pressure, furnace cell, even reaction cameras. You can make a whole experiment in a reaction camera and have it study with neutrons. This is possible. But this has a problem. Matter is almost hollow for neutrons. So that means that the same as we can use in our benefit this deep penetration of neutrons and make a nice thermal shielding for furnaces or cryostat, at the same time, we need a lot of sample, big crystals, or a lot of powder to see scattering from the neutrons. Okay, so it's just to compare furthermore, X-rays and neutrons. X-ray is almost a surface probe. Neutrons is volume probe. X-rays are sensible to the Z number. Neutrons are sensible to isotopic number. They can see differences between isotopes, huge differences. So for example, the substitution of hydrogen by deuterium is like having another completely different atom. Thinking on X-ray terms. Okay, so it is very common also to substitute hydrogen by deuterium when you make neutron experiments, because the problems related to hydrogen, which are not part of this talk, but so also because of these problems, okay, it's very common and is like another case. Like, sorry?
What the Z number and isotopic number is not independent.
No, what I want to say here is, good question. What I want to say here is that X-ray are sensible to the Z number. And yes, trying to follow the comparison, I wrote sensible to isotopic number, and your fellow tells me that this is different to this one. So in a given Z, I might have a lot of isotopes. But what I'm trying to say is that neutrons are essentially insensitive to Z, really are insensitive to Z, and can detect differences in isotopes. Okay? So they can distinguish two isotopes like if they were completely different atoms. Huge differences. Whereas X-rays are unable to distinguish between two isotopes in most of the cases. That's what I want to emphasize. Sorry, in fact, it can be improved, the rating. Thank you very much. So, it's difficult to see light atoms with X-rays. With neutrons, we get very good contrast. We can get very, very easy the hydrogen positions. Okay, yeah, I know what happens. We receive a huge number of photons in X-ray experiments. We have a very small number of neutrons, very low flux. So that is a problem in neutrons. We have very good resolution with X-rays. We have a medium resolution with neutrons. So we can detect the atomic positions of, the crystallographic position of very low weight atoms like hydrogen, very good, much better than with X-rays. But we have more problems because low flux, and we have in a smaller resolution. With X-rays, it's difficult to address problems related to magnetism. Magnetic circular recurrence using X-rays can give you information about some things. But with neutrons, we can see the moments. So we can determine the magnetic structure.